recommended you use the calculator. But this method allows us to find the vertex with a little bit less dependency on our calculator, okay? So we're used to standard form of a quadratic, ax squared plus bx plus c. That's standard form. That doesn't tell us anything about the intercepts, doesn't tell us anything about the vertex. The only thing that looking at that equation will tell us is the y-intercept. So this form tells us the vertex. HK is the vertex. Now notice there's a minus in front of the H. So that means that you're going to change the sign when you pull it out of the equation to identify what it is on the vertex. So for example, if we had y equals -2 times x plus 3 squared minus 4, then I could tell you right off the bat that the vertex is -3, -4. I changed the sign of the x, the y does not change signs. Now, can you tell me whether that's maximum or minimum by looking at the equation? Anybody have an idea? I've heard both. Anybody want to justify? A is negative. It is a maximum because A is negative. When A is negative, that parabola is going to open downward, so you have a maximum value. So the vertex form is actually pretty helpful when we're talking about determining things about a parabola based on its equation. So here's how we get there. If we start with something in standard form and we want to get to vertex form, we use completing the square. But there are a couple of caveats. We're not going to move anything to the other side. Everything's going to stay on the same side. So that means we're not going to move the constant term to the other side. We are going to slide it over a little bit, but we're not going to move it to the other side. And instead of adding the c to both sides, when we add it, then we're going to subtract it from the end because we're doing it to the same side. So this will make sense here in a second when we actually go through an example. So let's look at number 1 here. And actually, hang on, I have these on a handout. Let's look at this. 2x squared plus 12x plus 26. 2x squared plus 12x plus 26. So if we're going to start the process of completing the square, we're not going to move the constant to the other side. So that eliminates step number 1. We're not going to move that constant to the other side. So then what was the next step? After moving the constant, what did we do? What would we do next to this problem right here? Okay, we're skipping that step. We're skipping moving the c. What do we do next? We're not moving c to the other side, so what came after that, though? If we're completing the square, what came after that? Okay, what happened when a was not 1? We got to factor it out. Okay, we're going to factor out the 2, but we only take it out of the 2 terms that have the x's. Okay, so we're not taking the 2 out of the entire expression because 26 is divisible by 2, but we're just sliding the c over to the end. We're going to factor out that a like we normally would. Now we're going to keep completing the square. So here's where we divide what? 6 by 2. Okay, 6 divided by 2 is 3. And we square it and we get 9. So just like normal, we add 9 inside of our parentheses. What did we have to do when we had a number in front? We had to multiply, right? 2 times 9. Now we're not doing it on the other side, so we have to keep things balanced and we've got to subtract it. We subtract the 18 this time because what we've done is we've added 18 right here with the completing the square. I can't just add 18 to my equation without changing things. So if I subtract 18, technically I haven't really done anything to this. I've just written it in a different form. So it's on the same side, so if I add it inside my parentheses, I've got to subtract it outside the parentheses. Okay? Those are the only things that we have to remember that are different. Now we're just going to keep our process going. We factor x plus 3 squared. 26 minus 18 is 8. So our vertex is -3, +8, and is it a maximum or a minimum? Minimum, because A is positive, it's opening up, so it has a minimum value. Okay? So let's do another one. Let's look at number 5. Number 5 is y equals -2x squared plus 7. -2x squared plus 7. Are we missing something that all of our other equations have? We're missing a linear term. It's kind of hard to complete the square without a linear term because you don't have b. b is 0, so you're not going to be adding anything because 0 divided by 2 is 0. 0 squared is 0. So this is a little bit, I put this on here not to throw you for a loop, but just to show you that technically this is kind of sort of already in vertex form. I could just write this as -2 parentheses x minus 0 squared. X minus 0 squared is the same as x squared. Okay, but now it's technically in vertex form. Technically it was before, but it looks more like vertex form. So it's easier to see, oh, well, the x-coordinate of my vertex is 0. The y-coordinate is 7. Yes, that's the same as the y-intercept. Some parabolas have a vertex on the y-axis. Is it a maximum or minimum? Max, because A is negative. Okay, so we didn't actually have to do the process on number 5, but I wanted to show you how you can still pick out the vertex. Okay, let's do number 7. Number 7, y equals -1/4 x squared plus x plus 6. Okay, completing the square. We've got to factor out that a, -1/4. So remember what I told you. Factoring out is like dividing by fractions, like multiplying by the reciprocal. So that means that when we take out a -1/4 from a +1x, we're left with -4x. Leave yourself the space, close your parentheses, slide your constant outside of those parentheses. Okay, if that doesn't really make sense, remember you can multiply back out, or you can think of it as, okay, if I've got -1/4 out here, what do I have to multiply it by to end up with a +1? Well, -1/4 times -4, negative times negative is a positive, 1/4 times 4 is 1. Okay, let's complete the square. -4 divided by 2 is -2. -2 squared is +4. So we add 4 inside of our parentheses. We multiply it by our GCF. 4 times -1/4 is -1. And we subtract -1 from the end. So let's put this in vertex form. -1/4 times x minus 2 squared. Subtracting a negative is the same as adding a positive, so we've got +7 on the end. So our vertex is at +2, +7, maximum or minimum? Maximum, because A is negative. Now, let's talk about the reality of this on the final exam. If you had a question about this, the reason why I went through the whole process is because I have seen them ask questions like, what's the next step? Or find the error. This person was doing this problem turning standard form into vertex form, find their error. You've got to know what the steps are to be able to answer questions like that. But in reality, if they give you this standard form of a parabola, you can type it into your y equals, you can graph it, and you can find the vertex by calculating the maximum. And you can also use this to check yourself. After you do it, plug in your vertex form and make sure that you end up with the same function, the same graph, the same vertex, so forth and so on. You can use your calculator to help you out with these. I just want you to know the process as well, in case they ask you a question, like I was saying. What's the next step? Find the error, or something like that. You need to be familiar with the process, okay? So what I want you to do is I want you to practice with this on your worksheet there. I want you to do the rest of them, okay? We need to practice this with completing the squares. So you need to write each of these equations in vertex form. You need to identify the vertex and tell me whether the parabola opens up or down, that, maximum or minimum. Okay, tell me whether it's a maximum or minimum, whether the parabola opens up or down. Okay?